In this video, we're going to talk about derivatives of exponential functions. Now, since I'm doing all derivatives together, then I'm just going to go ahead and cover these as well. But exponential functions, the derivatives of exponential log functions are usually covered later in a calculus course. So if you just followed up my videos in order, you may have gotten to these before your instructor gets to the material. But if you want to get a jump on things, then just go ahead and watch this video. Okay, so as I said earlier, in these videos I'm not showing you theory, I'm just giving you what you need to do, what you need to know to survive. So first of all, if you take the derivative of e to the x with respect to x, then that's always just going to equal e to the x. So for instance, let's say I gave you this function 5e to the x minus 3x squared. Okay, well then the derivative of that function would actually be the derivative of 5e to the x. And so the derivative of 5e to the x would be 5 times the derivative of e to the x. Well, we just saw that the derivative of e to the x is just e to the x. So 5 times the derivative of e to the x would simply be 5e to the x. And then I just threw another term in for good measure. Minus 3x squared, the derivative of minus 3x squared is just minus 6x. Okay, now, but what if you're taking the derivative of e to the u, where u is some function of x? So, well, when you have that, you write the derivative of e to the u is e to the u times the derivative of u with respect to x. Or if you prefer, you could write that as e to the u times u prime. Okay, so this one looks very similar to the first one I did, but for this one, notice that the exponent here, x cubed, this is not just x, this is actually x cubed, a function of x. So what I have to do is, when I take the derivative of e to the x cubed, I follow this rule here. So the derivative of e to the u is equal to e to the u times u prime. Well, since the u here is x cubed, then the derivative of e to the x cubed is simply going to be e to the x cubed. But then I have to multiply by the derivative of x cubed. So the derivative of x cubed is 3x squared. So again, the derivative of e to the x cubed is simply e to the x cubed times the derivative of x cubed, which is 3x squared. Okay, so that gives me, for the derivative of e to the x cubed, I just get e to the x cubed times 3x squared, and I just bring down the 5 as the factor that was with it. So I have 5 times this, and then of course we know the derivative of 3x squared is 6x. Okay, now what I can do here, I can go ahead and multiply the 5 times the 3, and I'll get that simplified a little bit. 5 times 3 is 15, and I'll put the x squared to the left of e to the x cubed. So that would give me 15x squared e to the x cubed minus 6x after I simplify. Okay, let's look at some others here that we can take the derivative of. So if I have y equal x cubed plus 5e to the x, well, that's not going to be much different than this one here. I take the derivative of x cubed and I get 3x squared, and the derivative of 5e to the x would simply be 5 times e to the x, because the derivative of e to the x is just e to the x. Okay, but this one here, I actually have, notice here, number 2, I actually have y equals e to the x squared. So the derivative of e to the x squared, you take when you get the derivative of e to the x squared, you just use this formula right here, okay? And then, so you write e to the x squared, and then times the derivative of x squared. Now, I don't have to put this step in here, but I'm just trying to make sure you understand that you just multiply by the derivative of this exponent here. and the derivative of that exponent x squared is simply 2x. So you end up with 2x times e to the x squared for that one. Okay, let me go ahead and work one more here just to make sure you understand this concept before I work the last two. Okay, so here if I have y equals e to the sine x, the derivative of that, y prime, would equal e to the sine x, and then you would multiply by the derivative of sine x, and we know the derivative of sine x is cosine x. So there you can see I used this rule again, e to the u, the derivative of e to the u is e to the u times u prime. Okay, let's focus on number 3 here. Y equals 4x plus 3e to the x to the 4th. Now I want you to think about this one a minute. This, even though it has an e to the x in it, this is actually a power rule problem. You see that power right there? So anytime I have a function raised to a power, I apply the power rule. So I'm going to apply the power rule to this entire function, kind of like I did in a couple sections back. So when I take the derivative of this, I get 4 times this function, all of this function, and then remember you reduce the power by 1, so it would be 4 times that function to the 3rd power. But then remember what the chain rule says, specifically the general power rule. It says to multiply, then you multiply by the derivative of the inside, and the inside here is 4x plus 3e to the x. Now this just is the fixing to thing that I'm fixing to take the derivative. So in the last step I'll take the derivative. So the derivative of 4x is 4. The derivative of 3e to the x is just 3e to the x. So your final derivative is 4 times the expression here, 4x plus 3e to the x raised to the 3rd power, and then times 4 plus 3e to the x. Okay? Okay, so on number 4 here, I actually have a quotient, e to the x over x cubed. So I'm going to let u be e to the x, and I'm going to let v be x cubed, and I'm going to treat this as u over v, and I'm going to use the quotient rule. So if you refer back to your quotient rule, the quotient rule says you take the bottom, or the v, which is x cubed, and you multiply it by the derivative of u. Now, e to the x is u, but the derivative of e to the x is also e to the x. So u is equal to e to the x, and also u prime is equal to e to the x. So I would have v, which is x cubed, times the derivative e to the x, which is e to the x. Well, then I would take the numerator, u, which is e to the x, and multiply it by the derivative of the denominator. So the derivative of x cubed is 3x squared. And of course, we subtract these terms in the quotient rule. And then don't forget, in the denominator, you take the v and you square it. So I take x cubed and I square it. And of course, that'll give me x to the 6th when I square x cubed. Now, I went ahead and factored out what I could here. I actually was able to factor out an x squared out of both terms and an e to the x out of both terms. So factor the x squared e to the x out, and then I have just x minus 3 here. Now, really the main reason I did that was so that, you see I have this x squared on top, and if I cancel the x squared factor in the numerator into x to the 6th in the denominator, that will just give me x to the 4th power. So I end up with just e to the x times x minus 3 over x to the 4th for the final answer. Okay, this one I have y equals e to the 1 over x. And in order to take the derivative of that, I need to write 1 over x as x to the negative 1. And then that way I can use that property for the derivative of e to the u. So now remember, the derivative of e to the u is e to the u, and then times the derivative of that u. So the derivative of x to the negative 1. Well, if you apply the power rule to x to the negative 1, you'll get minus x to the negative 2. So what I end up with is minus x to the negative 2 times e to the x to the negative 1. Okay, so what I'm going to do here, I'm going to write this minus x to the negative 2 as just minus 1 over x squared. And then now I can rewrite this x to the negative 1 back as 1 over x. So I would have that multiplied by e to the 1 over x. And that would be the answer that you get there. Now I'm going to do one more of these. So this time, you see I have sine of e to the x squared. Now be careful here, because this problem here does not start out as a e to the u problem. This is actually, we have to use a trig rule here. I have to think of this as sine of u. So this is sine of u, where u is e to the x squared. Now remember, what's the derivative of sine u? It's cosine u, and then you multiply by the derivative of u. In this case, the u is e to the x squared. So we multiply by the derivative of e to the x squared. Okay, now to take the derivative of e to the x squared, I actually have to write that as, I have to think of this as e to the u, where u is x squared. And so the derivative of e to the u would be e to the u, so there's e to the u right there, e to the x squared. And then I multiply by the derivative of the u, so the derivative of x squared would be 2x. So I just kind of rearranged it. I wrote the cosine e to the x squared last, and then I wrote the derivative of this first. And the derivative of e to the x squared is 2x e to the x squared. Okay, I'm going to finish here with two formulas for the derivative of exponentials with bases other than e. So here, if you want to take the derivative of a to the x, then what you have to do is, that's just a to the x times the natural log of a. So if I wanted to take the derivative of 3 to the x, see, because 3 is not e, so I have to use this rule. So the derivative of 3 to the x would simply be 3 to the x times the natural log of 3. Now I know that's backward from I have it up here, but it doesn't matter which way you multiply. So that's 3 to the x times the natural log of 3. Okay, now, but what if it's a to the u? What if it's of the form a to the u, where u is a function of x? So if I have a to the u, where a is a constant and u is a function of x, then in that case the formula would be natural log of a times a to the u times u prime. Okay, so an example of that would be this example here. Here I have a, which is 3 to the 5x squared. Now let me emphasize, on both of these rules, a has to be a constant. Okay, so I have 3 to the 5x squared. Now to find the derivative of that, I just have to multiply natural log of a to the u, and u prime, and it doesn't matter what order I write them as long as I show they're multiplied. So let me just show you the natural log of a I have there, because a is 3, so I have the natural log of 3. And then I write a to the u, so a to the u would just be the 3 to the 5x squared, so I wrote that there. And then the u prime, that's actually the derivative of the exponent, and so the derivative of 5x squared is 10x. So there's my derivative, 10x times 3 to the 5x squared times the natural log of 3. And let me just leave you with one last thing. Some students think they can multiply the 10 times the 3 and get 30, but you can't because of the order of operations. 3 is actually raised to a power, so there's no way that you could multiply the 10 and the 3 together, since 3 is actually has an exponent with it. So we'll just leave it like that, or like I said, you could write the natural log of 3 in front of this if you put it in parentheses, or you could rearrange it other ways. But it basically has to have these three factors: 10x, 3 to the 5x squared, and natural log of 3. And of course, if this had been a number other than 3, like if this had been 7, then we would have had natural log of 7. If this had been 2, we would have had natural log of 2 here, and so Okay, so in the next one I'm going to talk about derivatives of logs.